Okay, the next thing we're going to be looking at here in section 4.2 is present value of an annuity. So this would be like a loan. So you're given a certain amount of money in order to do something, buy a car, live in a house. You have to pay that loan off. Okay, well, there's interest applied to these loans. So you're always going to be paying more than the sticker price of the car, unless you just pay cash straight up, for that car. And you're always going to be paying more than the sticker price, if you want to call it that, of a house. All right, and we'll talk about mortgages and amortization of that in the next section, 4.3. Anyway, if you're a formula person, here is the present value of an annuity model. So you can pause it if you like, write that down. The good news is you can still use the ever popular Finance TVM Solver app in your calculator to handle these problems as well. In fact, for the majority of these problems in sections 4.2 and 4.3, you can use, guess what, the app. Very, very exciting. Now, with that being said, I will show you the formula route just once here for present value. So P for present value here. And we're looking at what? R times the quantity of what? So now, present value, the model is going to be different, as you just saw in the previous slide. So it's 1 minus the quantity of 1 plus I. I is still what? I is still R over M. And this is going to be to the negative nth. All right? And N is still M times T. Okay, Mike Tango is what November N is equal to. And it's all over I. So if you're a formula person, you would do what? R is the payment amount. So 800 times what? Well, the quantity of 1 minus the quantity, 1 plus I, which in this case is, what's R? 6%. So in the formula, you do convert it to a decimal. All over what? Well, it's being compounded quarterly. So the M, Mike value, would be 4. To the negative what? To the negative M, as in Mike, times T, as in Tango, which is 7 years, okay? Closed quantity. And that's all over I again, which is right here, so 0.06 over 4. And let's see if we can do all this at once. So this gets pretty crazy once you get all that information, have all this information thrown at you at one time. But I'm going to try to do it all at once. So I'm going to do 800 times the quantity of what? I'm going to do second y equals, brings up that menu if you have an 84, for most 84s anyway. If you don't, you got to be really good at parentheses. That's why I suggest you just use the application. Anywho, let's keep going with the formula. If you are dead set on being a formula person, that's fine. I will show you that. I need to give you that option. That's fine. So let's go ahead and plug in the numbers. Let's see if we can do this. This is just, can you use your calculator correctly? So that would be to the what? Negative 4 and then 7. And that's all over 0.06 divided by 4. And we do get this amount. So this would be what? This would be the amount of the loan that you would need to, let's say, buy a used car. Okay? So the answer, what's the loan amount? Well, it'd be $18,181. And to the nearest cent would be 37 cents. Okay? All right. Now think about this. This is the loan amount. Let me just show you something real quick. This is what you're actually paying. These are the terms of this loan. So let's say you needed this additional amount to buy a used car or whatever, okay? They give you the car. You don't actually see this money. You get the car, right? And then you start paying off the loan at $800 every 3 months or quarterly for 7 years. Okay, so let's see what happens. If I do 800 times what? Quarterly times 4, that's 3,200, right? And then times 7, that's actually how much money you're paying. This is how much money you're paying the bank in order to drive away in this used car today. That's the loan amount, okay? But look, you're paying more than the loan amount. That should make sense because of interest. What is the interest? Well, it's the total amount of, all the payments you've made over the 7 years minus the loan amount. So I know this is not what I was asking for, but I'm just going into a little more depth here. So you will have paid about $4,200 in interest over the course of the loan over those 7 years. Hope that makes sense. If it doesn't, you got to reach out. You got to send me an email and we'll chat. Okay, the last example we're going to look at here in section 4.2 is another one on financing. So this is kind of what I was alluding to in the last problem. All right. If we were to put context around the information we looked at in the last problem, then it's going to be very similar to this one. So let's take a look. Lupe made a down payment of $8,000 toward the purchase of a new car. To pay the balance of the purchase price, she has secured a loan from her bank at the rate of 6% per year, compounded monthly. Under the terms of her finance agreement, she is required to make payments of $420 per month for 36 months. What is the cash price of the car? Okay, so we will worry about this $8,000 later. This is going to be handled separately versus the actual loan amount. This is just straight payment toward the principal amount. Okay, so we're not going to worry about that until the end. Okay, so what I'm going to do here is I'm going to write down some things. I'm going to write down I'm going to write down the information again using our TVM solver with our calculator. Okay, so bear with me one moment. All right, so what is N in this particular problem? Well, it says she is required to make payments of this amount per month for 36 months. So this is ultimately N. I know it doesn't say the total number of years, but what this is the same as is she's making monthly payments for 3 years, which would be 3 times 12, or 12 times 3, which would be 36. So N is 36. The interest rate is 6% per year. That's not uncommon, depending on your credit score for a used car. Present value is what we're going to be solving for. Okay, PV, present value you use for loans. Payment. Well, she's making a payment of $420 per month. Future value? Nope, not in this case. Not in this case because it's a loan. It's not future value. It's not a savings account. Payments per year, 12, which is the same as number of times compounded. So I go to my calculator. And N is going to be 36. Interest rate is 6. Present value is what we're solving for. Payments negative 420. Future value makes 0. Whatever one you're not solving for, make it a 0. Everything else is correct. So we go to present value, and what do? You hit alpha, enter, and there you go. We get the loan amount. This is the loan amount. So let me write this down. What is that? $13,805 and 83 cents. Okay, that's the loan amount. $13,805 and 83 cents. Now, so this is the loan amount, but then she also put cash down towards the principal immediately toward the price of the car, right? Which is $8,000. So you got to add the two together. Okay, you got to add the two together. So you can go back to your home screen. I mean, you can do this in your head, but you could do $13,805.83 plus $8,000. That's the actual sticker price of the car. Let's write that down. So this is the cash or sticker price of the automobile. Okay. So what I want you to start to do is begin to think about what the heck's going on here. We have one more section to look at, but already I want you to start thinking about this with a logical progression, okay? I want you to ask yourself the following questions. All right. How many payments? Based upon the given information, how many payments? Is it one or more than one? Okay. Well, if it's one payment, then that's like the material we talked about in section 4.1. So if it's one payment, how is that amount compounded? If it's not at all, then you use the simple interest model. If it's compounded periodically, let's say like quarterly or monthly, for example, you're going to use this model. And if it's compounded continuously, then you use PERT. All right? These three models will be used if just one payment, one deposit is made. Now, if more than one, then you need to ask yourself, will there be any money for me to withdraw at the end of the contract? Okay, at the end of the term. If the answer to that question is yes, then you're looking at a savings account, right? Will there be money for you to withdraw at the end of the term? Well, then that's going to be like a savings account. So that's going to be future value, and you'd use this model, okay? Or if you're using your application, you'd use FV in the calculator. That's what you'd be solving for, FV for future value. Now, if the answer to that same question, will there be any money for me to withdraw at the end of the contract? If the answer is no, then you're looking at a loan. You're trying to pay off the loan. And so that is a present value situation. This is the model you're going to use, or just simply use your calculator and solve for PV. Hope you're doing well. One more section to look at here. 4.3.